In this video, we're going to look at the graphs of tangent, secant, cosecant, and cotangent, or the reciprocal functions. So we want to be able to graph these functions on our calculator, be able to give the properties, domain, range, etc., and we want to be able to match these graphs with equations without using your calculator. All right, so what we want to do is be able to find some transformations of these graphs. So it's similar to the sine and cosine transformations, although we're just going to look at stretches and shrinks here, and we're not going to look at any shifts. So regardless of what equation I have here, they would all be somewhat in this form. So the number in front of tangent, cotangent, secant, cosecant, and then you could have a number in your parentheses with your argument. So your b value, remember we're going to kind of look at that as a reciprocal. So your vertical scale factor is going to be the absolute value of a. Your horizontal scale factor is going to be the absolute value of b. So notice, remember, this is reciprocal. So your transformation to your domain, your asymptotes, and your zeros. So your domain, your asymptotes, and your zeros will all be transformed in the same way. So all of these things you're going to multiply by the b value. And then any transformation to your range, you're going to multiply by the vertical change value, which is going to be your a value. If your domain or your range is all real numbers, remember, then no transformation will happen. So if your original domain or range is negative infinity to infinity, then the transformed value is the same. Okay, so if we look at a couple examples here, we want to describe the transformation and then give the domain and range, asymptotes and zeros of the new function. So what I've given you here are the domain, range, and asymptotes and zeros of the standard secant function. So my transformation here, remember, is going to be this 1/3. We're going to take the reciprocal. So this is going to be a horizontal stretch by factor of 3. And then we're going to have a vertical stretch by a factor of 2. And then remember, domain, asymptotes, and zeros are affected by your horizontal change, and so you're going to multiply by that b factor, and your range is going to get multiplied by the a factor. So my b factor is the horizontal change, it's 3. So my new transformations here, or my new properties from my transformed equation, is going to be all real numbers except odd multiples. And I'm going to multiply the pi over 2 by the 3. So odd multiples of 3 pi over 2. Same thing here with my asymptotes. My asymptotes are going to be at odd multiples of 3 pi over 2. I had no zeros before, so I'm going to have no zeros now. So if we multiply 0 by anything, we still get 0. And then remember, the range is going to get multiplied by the vertical scale change factor. So my new range is going to be negative infinity to negative 2, and then 2 to infinity. We can use your calculator to check that. So remember, make sure you're in radian mode. So my calculator's in radian mode. Then I'm going to go to my y equals, and I'm going to type in the function here. So I've got 2. Remember, secant is 1 over cosine, so I'm going to divide by cosine. And then I have 1/3 of x. And then I'm going to do a zoom 7. So then if I want to check where my asymptotes are, so we think our asymptotes are at odd multiples of 3 pi over 2. So I'm going to trace. When I try 3 pi over 2, I get y equals nothing, which confirms that that's an asymptote. So we could also try negative 3 pi over 2. And again, we get y equals nothing, so we know that that's an asymptote. I could check this minimum value here just to check for my range. So I'll try that. So minimum. And I can see I'm getting the y equals 2, so that is confirming my range for me. All right, so here's a similar example. So again, I'm going to talk about my transformations first. So I'm going to deal with this pi. So 1 over pi is going to be a number that is less than 1. So this is going to be a horizontal shrink by factor 1 over pi. And then the 3 out front is going to be my vertical stretch by a factor of 3. Again, I gave you the standard properties here for a cosecant graph. So our new properties, remember domain, asymptotes, and zeros are going to get multiplied by our horizontal value. So I'm going to multiply by 1 over pi, I'm going to multiply by 1 over pi. Here I'd multiply by 1 over pi, but they don't exist. So once we multiply, they're still not going to exist. So here my domain is going to be all real numbers except multiples. The pi's are going to cancel out here, and we're just going to get 1. And then here my asymptotes are going to be at multiples of 1 as well. Still have no zeros. And then for my range, remember we're going to multiply by the vertical value, which is 3. So my range is going to be -infinity to -3, and then 3 to infinity. Again, if we use our calculator, so this one will be 3 divided by sine. And then we have pi times x. So taking a look at my graph, remember we think that our exceptions in our domain and our asymptotes are happening at multiples of 1. So I'm going to try that. So I'm going to do second trace value at x equals 1, we get y equals nothing. At x equals 2, we get y equals nothing. At x equals -1, we get y equals nothing. All right, so on this one we have tangent. So my transformation here is going to be horizontal shrink, because remember we have to take the reciprocal there. So horizontal shrink by a factor 1/2. And then we've got a vertical shrink by a factor of 1/3. Doing my transformations, remember domain, asymptotes, and zeros are going to get multiplied by our horizontal change. So we're going to multiply by 1/2, multiply by 1/2, we're going to multiply by 1/2. So this is going to give me a domain of all real numbers except odd multiples of pi over 4. So then my asymptotes are going to be, again, at those odd multiples of pi over 4. And my zeros are going to be at multiples of pi over 2. Your range was all real numbers, so it's going to stay all real numbers. So -infinity to infinity. Again, here, if you want to check with your calculator, we'll have 1/3 tangent 2x. So we think we have asymptotes at the odd multiples of pi over 4. So we can try pi divided by 4. Y equals nothing. So then we wouldn't try 2 pi over 4 because it's only odd multiples. So we would do 3 pi over 4. So if we check negative pi over 4, we got y equals nothing again. Here we can also check our zeros, and they're multiples of pi over 2. So if we check that, if we go pi divided by 2, we get y equals 0. We can try negative pi divided by 2, and we get 0. So we could try 2 pi divided by 2, which is just pi. But we can see we're getting 0 again. Okay, so on this last one, our transformation is going to be a horizontal. Remember, we're going to take the reciprocal here, so 3 divided by pi is going to be less than 1. So a horizontal shrink by factor 3 over pi. No vertical change here, so we don't have to worry about that. So that horizontal scale change is going to get multiplied to my domain, my asymptotes, and my zeros. So my new domain is going to be all real numbers except multiples of 3. So my asymptotes are going to be at all multiples of 3. And then my zeros are going to be at odd multiples of 3/2. Remember, in your calculator here with cotangent, I would graph it as cosine over sine. So just do cosine of pi x over 3 divided by sine pi x over 3. So if we check our asymptotes, x equals 3, x equal -3. And then I'm going to check my zeros. So those are at odd multiples of 3/2. So x equals 3/2, we get a 0. So then we could try an odd multiple. So then it would be 3 times 3/2 or 9/2. and we get y equals 0 again.